Okay, I think we can start now. Um, First off, a very warm welcome to each and every one of you. My name is Aslam, and I'm the president of the University of Chicago Booth Singapore Alumni Club. Thank you for all for signing up and for attending this webinar. This is the first in a series of webinars we intend to hold as the Alumni Club. And today we have a fantastic program where we will talk about vaccines versus test kits, the way forward for economic reopening under the current COVID-19 pandemic situation. So without further ado, I would like to introduce our speakers and then pass over to our moderator. So today, go to the speakers. Lenora, can you shift to the speakers, the next slide? Okay, so today we have three illustrious speakers, the first being Professor Wee Eng Ong. He's the professor and deputy director of the Emerging Infectious Diseases Program at the Duke NUS Medical School. He holds an appointment as professor at Saw Swee Hock School of Public Health and Yong Lu Lin School of Medicine, National University of Singapore. Professor Wee plays a key role in the current ongoing efforts by Duke NUS to develop a vaccine for SARS-CoV-2, the COVID-19 coronavirus. He was instrumental to the partnership signed between Duke NUS and US biotech Arcturus Therapeutics, a NASDAQ-listed company, which will see the development of a COVID-19 vaccine based on the Arcturus STAR technology and take advantage of a unique platform developed at Duke NUS, allowing rapid screening of vaccines for effectiveness and safety. He's the recipient of the Clinician Scientist Senior Investigator Award by the National Medical Research Council of Singapore in 2010, 2014, and 2018. Professor Wee has also frequently appeared in media such as NBC, Singapore Straits Times, and Today to talk about the current issues of the coronavirus. So let us welcome him. We are very happy to have you, Professor Wee.
Thanks for having me. Thank you.
Our second speaker is Dr. Wang Qingying. Dr. Wang is currently the Chief Operation Officer of an SGX-listed company, Biolytics. She joined the company in October 2018 as an Associate Director, Scientific Advisory and Integration, on secondment from Clearbridge Medical Group Private Limited. She was appointed the Chief Operating Officer of Biolytics in July 2018 and is responsible for overseeing the operations of the company for more than 12 years. Dr. Wang was an investigator of Novartis Institute of Tropical Disease Private Limited. During her time as principal scientist at Novartis Institute for Tropical Diseases, Dr. Wang established a laboratory specializing in the development of various cell-based assays to support all stages of drug delivery. Dr. Wang is the author of over 30 papers published in peer-reviewed journals. She presents her work frequently at national and international conferences and has written numerous books, chapters, and invited reviews. Dr. Wang obtained her PhD in molecular virology from Chicago's University of Illinois and completed her postdoctoral training at Harvard Medical School. She also has an MBA degree from NBS, the Nanyang Business School, NTU, through the Executive MBA General Management Track Program. And then we have our very own Dr. Anselmo Chung, who is a fellow Chicago Booth alum, who recently graduated, I believe, AXP 20. Dr. Chung is currently the Managing Director and Partner for EY Parthenon, taking care of life sciences and healthcare strategy for Japan and APAC regions. He's also the Adjunct Associate Professor for Johns Hopkins Bloomberg School of Public Health, teaching a class in improving the quality of medicine in healthcare. Prior to that, Dr. Chung has also taken leadership roles in Monitor, Deloitte, Ernst & Young, and PwC. Dr. Chung holds a doctoral degree of public health Health Policy and Management from Johns Hopkins Bloomberg School of Public Health, and an MBA from the University of Chicago Booth School of Business. Today, moderating the event at the webinar will be Dr. Lee Ming Ming, also a fellow Chicago Booth alum. Dr. Lee is currently the Director of Group Biodiagnostics, SBU for Cod Life Group. He is responsible for driving the organic and inorganic growth of the business units with pipelines across Asia. He is a volunteer inspector for 2 international organizations, the Foundations for the Accreditation of Cellular Therapies and American Association of Blood Banks. Dr. Lee holds 2 advanced degrees of biotechnology and an MBA from the University of Chicago Booth School of Business. He recently joined us as an executive member of the Chicago Booth Alumni Club, so we are very pleased to have him. Today we have a really illustrious group with her, all PhDs. So I would now pass the baton to Dr. Lee to take over and run the session. Dr. Lee.
Thanks, Aslan. Thanks, Aslan. Lenora, can we go to the next slide? Before we start, right, let's just share a few notes to get familiarized with the Zoom software. So first, this webinar is recorded. You will be put on mute by default. So when you post questions, right, please use the Q&A tab to write the questions in, and don't use the chat box, please. And during the Q&A session, you will be unmuted. Please raise a hand before speaking. So by now, right, I'm sure everybody will be very familiar with the SARS coronavirus 2 already. This virus has paralyzed the whole world since it first appeared end of last year in China. Why it caused so much concern of the medical community and also the general community is that it's spreading very fast, and it causes ARDS, which is acute respiratory distress syndrome. The widespread inflammation of the lung causing the respiratory failure. It can also lead to systematic failures and organ failures as well. So there's no convincing report for now showing any drugs can effectively eliminate this virus from our body. Hence, vaccine development and effective or regular testing could be the solution to protect us and stop the pandemic. So Prof. Oi is the world-class researcher that can help us to understand more of this pandemic, and also he has been involved in many of the clinical trials as well as vaccine developments for COVID-19. So without further ado, let's welcome Prof. Oi to start the presentation.
Thanks very much, Ming. Thank you once again for inviting me to this webinar. It's a pleasure to interact with you all. I've been asked to talk about COVID-19 vaccine, and I'll give you a snapshot of what are the different kinds of vaccines, and then perhaps spend the next few minutes explaining how vaccines work to protect the population from this disease. And then we'll maybe leave it as that and show you how we're thinking about moving vaccines very quickly from concept to clinical trials. And then maybe after that, we can have a Q&A and all that. So next slide, please. So this is a slide just to give you an overview of what are the different kinds of vaccines. So at the last count, I think we're well over 150 different COVID-19 vaccine development efforts around the world. Many are still in the lab stage. Some have reached clinical trials. And these are the different kinds of vaccines. So what's a vaccine? So in the middle is a virus, and that's what would, for example, your SARS coronavirus 2 that causes this disease that Dr. Lee just described, this COVID-19, and people with very severe respiratory infection develop the syndrome called acute respiratory distress syndrome, or ARDS. So what we want to do with a vaccine is basically to activate the immune response to recognize this virus before you get infected, right? Because the way the immune system would work is that when you're infected with the SARS coronavirus 2, once you recover, you remember that you've you've been infected with this virus, and therefore that will protect you from getting the second infection if this virus were to get into your system all over again. So how do you get the body to remember this virus? Well, there's several ways. Ideally, if we start from the top left-hand corner, and then we go in the anti-clockwise direction, right? So ideally, we have a live attenuated vaccine. So a live vaccine basically is just that. It is a SARS coronavirus 2. It is alive, but it has acquired some mutations in its genome such that it's weakened. So it can cause an infection, but it won't cause disease, right? That's the ideal vaccine. And the reason why it's ideal is because this vaccine will simulate the entire process of infection. That allows your body to see not only the virus, but also the infected cells and what happens to the infected cells, and then all the way through to recovery. So it remembers the entire process. One way of thinking about this is, if I were to ask you to remember a person, I can flash a picture of this person and say, here you go, in 5 seconds, remember this face, right? And some of you would, some of you won't. Now, if I send you a picture by email, then you can look at this again and again, and probably then more of you will remember that face. What's even better is if I give you a video of that person. And then now not only do you see the face, you see the body, you see how this person moves, you hear how he talks or she talks, and so on. So your ability to recognize that person increases when you see more and more of the person, and in this case, the virus, right? But live vaccines are hard to make, because this is quite a dangerous virus. It's already in a biosafety level 3 kind of lab, so it's a high containment lab. So you need to make sure that the mutation really and truly weakens the virus, and that then the virus also cannot spread, because if it can spread, it can also acquire mutations and get back to the old cell, right? So live attenuated vaccines are not easy to make. So because of that, all the other efforts around the world right now are focused on all the other vaccines shown in this diagram, from inactivated vaccines, split inactivated, the peptides. Peptides are just parts of the protein. Then you can make virus-like particles. In other words, there's an empty shell, there's nothing inside, there's no genome, so it's just a shell of the virus. You can use the nucleic acid, the genes, and the encode for the key parts of the virus, and in this case, it's the spike. So in the middle of the diagram, the virus picture, you see all these things sticking out. That's a spike that looks like a lollipop. That's the spike. And the virus uses a spike like a key to unlock the door to get into the cell, right? So the vaccine, then most of these show the immune system the spike, so that we can develop antibodies that will block this key from slotting into the lock. So you can use DNA, you can use all the other like recombinant units and vectors, etc. So the whole idea there is that you're now no longer showing the entire video, you're just showing a snapshot of the virus. Okay, so next slide, please. Okay, so how does the vaccine work? So what we know, of course, is that when a person is vaccinated, then you're protected from the infection for at least a while, right? Ideally for a long time, if not for the rest of your life. But then there are very, very few vaccines that, with one vaccination will protect you for life. Arguably, the only one that can do that is yellow fever. So if we have been vaccinated, then we should be protected against infection. But vaccination does a second thing. It protects those that cannot be vaccinated as well. So you don't need, so technically in the population, you don't, like Singapore, about nearly 6 million, you don't actually need all 6 million to be vaccinated. You only need to vaccinate enough people so that the chance of the virus coming in contact with someone who's not vaccinated is small. Okay, so I'm going to illustrate that in this series next few slides. So let's assume that you have this is a population, so each blue dot is one person, and everything in blue means they have no immunity. Okay, next slide, please. So if someone with COVID-19 comes into this population, so that's the one in red right at the bottom of the left-hand corner of the screen, then this person is infectious and potentially pass the coronavirus on to others. Next slide, please. So on average, what we know now, if we, have some level of control, we don't let it go overboard, the virus, one person will spread to an average of 2 people, right? So 2 people then spread to 4, 4 then spread to 8, and that's how it grows exponentially. So if you have no immunity in this population, anytime and every time one person comes in contact with another person, there's a chance that the virus could be passed on to that person, and so on and so forth. And that's why you get an outbreak. Yeah. So next slide, please. Now let's assume now that it's the same population, same number of dots, but now some of them are immune to SARS coronavirus 2, right? And that's colored in purple. So if we now play that same scenario again, next slide, please. You now see that actually not every encounter results in an infection, because because there are more purple dots than blue dots, then the chance of someone who's infectious coming in contact with someone who's not immune is very small. You're more likely to meet someone who is immune. Right? So technically, you don't need to vaccinate everyone. Even the most infectious virus like measles, arguably the most infectious virus in the world, you only need to vaccinate 95% of the population and there'll be no more measles. To get rid of smallpox, we vaccinated 80% of the population and we got rid of smallpox. Right? So it depends on how well this virus spreads, and then you can back calculate what proportion of the population needs to be immune, and therefore then you vaccinate the population. Okay, so next slide, please. So we technically we can get a vaccine that then can protect a place like Singapore and get us back to some sense of normality. The problem and the real challenge with vaccine development is what you see in blue on the top of the screen, right? To get from the point where you identify what the target is, in this case, the spike protein of the coronavirus, the key to unlocking the cell, from the left-hand side to get all the way to the right-hand side, in other words, a licensed vaccine, right now it takes about, at best, 10 years, right? If you average, it's about 15 years. It's a long time. We can't wait 15 years to get a COVID-19 vaccine. So obviously something else has to be done, right? So how do we shorten this process? As you can see in the news, several vaccines have already gotten into phase 1 clinical trial. So what you see on the screen, on the top left-hand corner of the screen, the top arrow is about 5 to 10 years. Now companies are doing it in 3 to 6 months. Yeah, so that's a big improvement, but it's still based on what they've done in the past. So in other words, these platforms that I showed you earlier, the different kinds of vaccines, they've been used before in humans. And so what companies have done is that they've said, look, this is not the first time this is going to human. We've done it before. And so based on the past safety record, we propose a more accelerated pathway. So that's how they've done it, right? But now the next challenge is that once you go into humans, you still need quite a lot of people to test the vaccine in, because you want the chance to be able to see that the vaccinated person actually came in contact with someone who had COVID-19, but still remained protected from infection, right? So you need a lot of people. So for example, to test the dengue vaccine, Sanofi Pasteur vaccinated 30,000 children just to know whether it worked or not. So that's going to take a long time to recruit that number of patients. So how can we shrink this process further? So can you go to the last slide, please? Next slide. Okay, so how are we going to do that? So it turns out that we actually have a lot of tools now to understand what happens. So how the kind of immunity we develop from a vaccine is shaped by how we respond to the vaccine, right? So once you vaccinate, you receive the vaccine, your body will undergo trigger a series of processes that then leads to immunity. And a lot of these processes are in the form of activating or switching on or switching off your genes, right? So instead of waiting to get from the left-hand side, you see the people, right, the 0, and all the way to the right-hand side, which depending on what kind of trial you do, it can be 1 month, it can be 6 months, it can be years. Instead of waiting for years, by looking at what genes are switched on and switched off, within the first 1 week or so, we can actually predict what's going to happen in 1 to 6 months' time, what kind of immunity you will develop, and whether that's going to protect you. The other thing about vaccines is not whether it works to protect you, but whether it's also safe, right? So you need two things: safety and efficacy. And likewise, whether the vaccine is safe is also can be seen or gleaned from the kind of genes that are turned on and off after you receive the vaccine. Because whether you get a headache, whether you get fever, whether you get body ache or not, are all dependent on what genes are turned on and turned off. So right now, where we are at is that we can kind of, based on the genes that we see we are turned on and off, we can tell very quickly whether the vaccine is going to be safe and whether it has a chance of working. Unfortunately, we won't be able to say that it will work, but whether it has a chance of working. And all that within 7 days of you receiving a vaccine, we don't need to wait that long. So that's part of the strategy that we, at least in Singapore, are working with actors to take this kind of molecular approach to defining how well a vaccine would work, what kind of dose you need, how many doses you need, work all that out based on genes rather than based on this long-term observation. So I'll just stop there, and we can always revisit this at the Q&A, but that's hopefully a useful overview of how vaccines work and how we can apply it to stop COVID-19.
Thanks, Prof. Oi. I'm sure that we all have gained the basic understanding of how vaccine is developed based on Prof. Oi's slides, and how can we stop the pandemic through vaccine injections. And our next speaker is Dr. Wang Qingyin. There's a queue. Jerry just asked a question. Maybe we will open the Q&A session after all the speakers has shown their slides. So let's go to the next topic that Dr. Wang Qingyin will talk about the COVID-19 test kits. Dr. Wang has been working on test kit developments in Biolytics. Actually, Biolytics has one COVID-19 rapid test in the market already. So I guess Dr. Wang will be a very good speaker in terms of letting us know how COVID test is developed. Dr. Wang, please.
Okay, hi, good evening, everyone. Thanks, first of all, thanks Ming Ming for inviting me to give a presentation or short talk about this COVID-19 test kit. So today I'm going to share with everyone our thoughts on what we have known about this COVID-19 test, and we think we might know, and also pose up some of the questions that we don't know about the test kit about this COVID-19, because this virus is really new into our world. So there's a lot of unknowns that we need to explore, and then needs a lot of science and research to improve our understanding about the molecular characteristics of this COVID-19, as well as the pathogenesis of this COVID-19 virus. Yeah, next up, please. So pretty much, I think maybe some of you might heard about this test. So in general, the test for the COVID-19 diseases can be divided or can be categorized into two broad categories. One is the molecular test, and the other is the antibody test. So the molecular test, what we are looking at. So we are basically looking at the genome of the virus, just like looking at the DNA of a human. In this case, because the virus carries RNA as their genetic material, so we are looking at RNA of this virus. So the molecular test is still considered as the gold standard for the diagnostic test for COVID-19 in Singapore as well as worldwide. So for diagnostic purpose, molecular test or the nucleic acid detection test is still the gold standard to tell a person whether this person has has been infected by the COVID-19 virus, which in this case is the SARS coronavirus 2 virus. Okay, but the drawback of this molecular test is, of course, it requires a lot of laboratory. It's considered as a laboratory testing. So it's not a normal lab that can do all those like health screening, the clinical chemistry test, but it requires some containment. Because the virus, as Prof. Inyon said, is very highly contagious. So we have to protect the operator or the lab personnel from contracting these viruses during this testing. So we need at least a biosafety level 2 containment infrastructure to perform the test. And also, as you can see in the picture, that the person who is performing the test requires biosafety level 3 gears. So these infrastructure, as well as all these lab personnel skills, requires a very high level standard of this molecular test. So this is one of the drawbacks of this molecular testing. But on the other hand, the molecular test is, as I said, is considered a gold standard because it's very sensitive and as well as specific. So in any of the diagnostic tests, these are the 2 parameters that usually people are looking at. One is the sensitivity, which tells you how sensitive that you can pick up the disease among the population. And also the specificity is also important. So the specificity is just tells you, okay, so after this test, I'm 100% sure that you have this SARS coronavirus 2, but not the other like related human coronavirus. So both the sensitivity and specificity for the molecular test, they are very good. So that's why they consider as the gold standard for a diagnostic kit. But on the other hand, the antibody test, which is also called known as a serology test. So what are the modalities in this test measuring? So basically, we are not measuring the virus itself. We are not measuring the virus genome or virus nucleic acid. What we are measuring is measuring the immune response, the human body response to the SARS coronavirus 2 infection. So this is how the idea, the vaccine development, because every time when people see the virus, the human immune system will generate the defense system. So one of them is to produce the antibody to fight against the virus infection. So for the serology test, on the other hand, requires less, I won't say it's less skill, but it requires some certain of the skills and also certain of the settings. But compared to the molecular test, we can see that this test can be administered in a doctor's office and can be performed by a trained nurse or any trained of the healthcare workers. Because it's quite straightforward. Simply, it's just the blood drawn from your venous blood. Then you just put it onto the test cartridge and then wait 10 minutes, you get your results. But for the laboratory test, the molecular test on top requires at least 2 to 3 a few hours to finish the processing of the sample, and you will get the results. So these are the advantage of the serology test, which can be administered in a point of care setting, which means that it can be scalable rather than, unlike the molecular test, it has to be done in a designated laboratory settings. Yeah, next. Okay, so this chart just summarize the current landscape of the regulatory approval of the COVID-19 test, the molecular test, including the molecular test as well as the antibody test. Because of the since the COVID-19 outbreak, so it posed a very it posed a threat for the public health. So all the jurisdictions or regulatory bodies have opened up this green channel. We call it emergency approval channel to approve the COVID-19 diagnostic test. Because we all know that for a diagnostic test or medical device to be used as a clinical tool to diagnose a patient with certain clinical disease, it requires a very long and then rigorous review process. Usually it takes not months, but sometimes even years to get the approval from respective jurisdiction. So because of this outbreak, pandemic threat, so all the government has opened this emergency approval channel. Here I just listed a few that might be relevant. One is the Singapore, the health science authorities. They open up the provisional authorization route for all the COVID-19 tests, as well as the FDA. FDA is called the Emergency Use Authorization route. In China, situation is a little bit different. So it still goes through the China FDA, now known as the NMPA. So it still although it's a green channel process, but requires certain amount of clinical validation, at least in 3 independent medical institutions. Whereas for Singapore, as well as even in the US, these clinical trials is not required for the moment. As long as the technical data of the COVID-19 test fulfill the minimum sensitivity and specificity, you will be able to submit for the regulatory approval process. Yeah. But in China, because of the winding down of the COVID-19 cases, all these green channel for the NMPA approval now is closed. But the situation outside of China, because the COVID-19 situation is still growing, so both the HSA and FDA are still accepting new applications. Yeah, next. So this cartoon just tell us when, at what stage that these 2 tests that I mentioned, one is the PCR test or the molecular test, the other is the antibody test, which is the serology test that can be used in the clinical setting. So the y-axis we're just looking at is the disease duration, or we call it the symptom onset. So usually during the early phase, where the symptom onset start from the symptom onset until the day 7 or first week, at this point of time, because of the active acute virus infection is still ongoing, then so the PCR is the gold standard for the diagnosis. And also this is the current MOH guideline for using the PCR test as the diagnosis tool for COVID-19 infection. Because it takes some time for the human body to generate this immune response to attack the virus infection. So usually after 1 week and even later stage of during the disease course, then you will be able to start to be able to detect the antibodies. So here listed in the dotted line are the antibodies. One is called the IgM, the other is the IgG. So it's the IgG, which is the green dotted line, that give you a long-term immunity, that probably give you a long-term protection. So for the IgM, usually during a virus infection, usually it's the IgM comes first, followed by the IgG. But there are some of the publications that published by the Chinese medical institutions has shown that the kinetics of this antibody appearance in this COVID-19 patient might be a little bit from what our usual understanding. That is, the appearance of IgM and IgG can occur simultaneously, meaning that IgG will come probably at the same time as IgM, if not, it won't be delayed too much. So, so as I said, so this chart just gave you a brief overview about at what stage, what kind of test might be useful. Early stage, we want to know, do I have the virus? So at this time point, is the PCR test can give you a definite answer. But later on, during the infection, when the immune system kicks in and you start to generate antibodies, And at the same time, the virus, to clear off the virus infection, at this point of time, some of the virus load, we call it virus load, meaning the concentration of virus in your body might go down. As shown in here is the pink line and the pink solid line and the blue solid line. So during this stage, week 2 or week 3, your immune system kicks in to clear off the virus infection. At this time point, maybe the PCR might not be sensitive enough to pick up the infection. So at this time, maybe it's the combination of using both the PCR as well as the antibody test kit can give you a higher sensitivity and as well as the specificity. So, yeah. And then later during the stage, when really the antibody is very high, and then the virus load is coming down significantly at this time point, maybe week 3 onwards, is the antibody detection might be useful to tell you whether I had the virus or not. So this is just a graph based on the individual person level, people level, to see how we can use these two test kits. But on a larger population wise, next slide. So what is the usage of this serology test or the antibody test? So this serology test and antibody test at community level or national level or even global level can help us to understand what we call it sero-epidemiological studies. So what this entails is that you can have a broader picture to understand what is the seroprevalence rate in the population, in the community, or in the national or even at the international level. So you can by comparing all these serosurveillance data to find out what are the factors, to understand what are the factors might be very effective in contain the virus spreading, contain the virus infection. So this will change your public health policy or public health rules. And then beyond this understanding of the factors to determine the containment or the effectiveness of the containment, the other usage of this sero-epidemiological study is to identify the susceptible population that might be benefit from the vaccine. So as Prof. Inyong just mentioned, that you don't need to do 100% vaccination for all the population, but maybe we can use the limited resource using the data, the serosurveillance data, to find out what are the most susceptible population, then give them protective to give them the vaccine, let them to develop protective immunity, so we can have a very effective way to stop the virus spreading. Yeah, so I think I will end up here. Yeah, thank you.
Thanks, Dr. Wang. That's a very detailed explanation of how test kits were developed in terms of the molecular diagnostic PCR test, which actually was used in all the government hospitals in Singapore, right? And also the antibody test that can be point of care in all the clinics. So I guess everybody has gained a deep understanding of how which type of test kit can be used at what time. So I will leave there are a few questions raised already, but I will leave the questions to the Q&A session. And next, let's hear Dr. Anson Chong talking about the industry impacts of COVID-19. Dr. Chong, please.
Great, thanks everybody. Thanks for this opportunity to speak. I think we've heard some great explanations related to the virus and how it affects the body, and then the testing on the different types of tests to identify. Now we're going to take a little bit of a different pivot here and look at what this COVID-19 has done across different sectors, and maybe give some high-level strategies on how to cope. So next slide. I've been introduced, so I don't think we spend more time, but this is me, Anselmo Chung. I work for EY Parthenon, which is a strategy house within the larger EY firm. My focus there is leading life science strategy, mainly during commercial market strategy and mergers and acquisition strategies to help our life science and healthcare clients improve their business. So next slide. And then one more. Okay, so what we will talk about is looking at different sectors and looking at how COVID-19's really impacted the industries, cross industries. But as we know, COVID-19's really hit us pretty hard in both physical effects and also impacting economies. What we're seeing from a macro level is that we want to see a really quick rebound, obviously. But as you may have heard, there's been reinfections and we're not quite sure when these therapies and vaccines will come out. So I think it's safe to say that we should expect to see some bounce back or return to normal, as they say, sometime in 2021. So what does that mean for the rest of 2020 is a big question for a lot of the industries out there. All sectors, as we know, are affected, and impacts vary across industries. And there's a saying that you may have heard: we are in the same storm, but not in the same boat. So it impacts us differently. So we've categorized maybe 4 different industries into maybe 4 categories: strong, transformed, reshaped, and unknown. So what we mean by strong is industries that were already strong in economy or in growth pre-COVID, and then they're going to come out of COVID even stronger. For example, consumer tech like Apple's and Netflix and Amazon, those kinds of technology companies that are already built for this social distance world. And some pharma companies are already positioned, which have instituted a lot of these technologies to really advance how they connect with patients and their clients better. So transform, some of these industries that are in this transform buckets are industries that were doing well previous to COVID. And then it's really hit them hard. And now they're going to have to really think about what their operating model is going to be. Maybe inject some digital capabilities that weren't really a part of their operating model, like AI and robotics, to really enhance their value to the customers. And then reshape. So these are companies or industries and companies that were struggling, and you could already see their decline. But COVID-19 has just really hit them hard. And they look like they're really going to suffer, even coming out worse. And COVID-19 has probably accelerated their demise, exiting. So like oil and gas companies, we've already seen demand going down for the past 6 or 7 years. And then now COVID-19, as you can imagine, nobody's really traveling, flying, or anything like that. So what are they going to do? What is their new operating model going to be? And like physical retail stores, like big department stores, are really struggling as well. And then unknown industries like travel. Like, what is travel going to be like after COVID-19? Right? A few years after COVID-19, even where travel is going to be something that's a big unknown. So what are some of the strategies that they need to take into consideration now so that they survive? And that's the big unknown. So what we advise clients across industries is obviously you need to take steps now, right? That's, I think we're already like 3 or 4 months into COVID-19 react situation. So what is the now? And then what do you have to plan for next to reposition yourselves for after COVID-19 or beyond? And what we're expecting is this, in every industry you have a dominant player, and everybody's kind of trying to catch the dominant player, but we should see some switches where a dominant player that may not have planned for the next and the beyond appropriately, and really understand what the voice of the customers are saying and what their needs are, and react to that or plan for that, where some of the lower tiered or less dominant players in that same industry have reacted faster, and they now are able to shift into the post-COVID world better. And then you may start to see some market share shifting. that's where our expectations are. So next slide. So this is an interesting tiled graphic. You may have seen something like this in other publications. And I'll just put a caveat here that this is 2 months old. And 2 months in this rapidly changing environment is like decades old information to, you know, in some respects. But there are a couple tiles, maybe 1 or 2 tiles here worth mentioning. The bottom left that says 79% of board members state that their organizations are not very well prepared for this crisis. I would say more than 79%, maybe 100% of organizations were never fully prepared for such a global impact like this pandemic. And let's just really quick, I think we're running out of time a little bit. So on the right graphic there, you know, percentage of 150 largest companies mentioning COVID-19 in their quarterly earnings. So that's this first quarter ending in February. You know, you can see the worry in these top C-suite executive discussions on how that's really impacting their business. So what does that mean? The questions that will come out is what does that mean for the current strategy, or this current fiscal year strategy? Is it do we you know, save cash and just weather the storm, or do we be aggressive and looking to really take advantage of some of the changing dynamics and really go for it? So it's very interesting, and it all depends on which industry you're in, whether you're in that strong or that unknown industry, on how some of these executives are reacting to this. So next slide. So I thought this was an interesting graphic to show, and I think most, if not all of us, are in the APAC region. I think this is one of the few feel-good slides that I have. What this graphic shows you is that, you know, the Asian countries, or in China as a market of its own, as a power of its own. Let me just give you a little bit of a icon. So the middle graph there is the triangle, and that's kind of what the IMF is saying is a base case scenario for 2020, so the rest of the year. So if you look at ASEAN, you know, we're expecting to see obviously a drop in production, so about 1.3% growth or negative growth this year. But next year, you know, we should see a positive scenario, and in China as well, the impact is less severe. But the comparison is obviously U.S., as you've seen in the news, that they're not really able to control this pandemic or epidemic in U.S. at all. Pretty much it's going wild. So we should see a real big slowdown even next year. This year is going to be a pretty big impact, but even next year should be a challenge for their recovery. So I know we're in a connected world, where the U.S. market is a real big driver of global market, but in terms of recovery in a region level, I think ASEAN and China and just Asian countries in general would be in a better position to come out. So I explained a little bit ago how, you know, if you're able to plan for the beyond and take advantage, there are some strategic advantages from of planning for the beyond. And taking market share from the dominant player. So this is just kind of that theme. Next slide. So the economic outlook is still very dynamic, and as you can see from stock markets, although, you know, the U.S. market is just really crazily just rebounding pretty high, and some of the tech firms like Apple's to Microsoft are hitting, you know, all-time highs, which I still don't understand. So please ping me if you have an answer to that, so I understand that much better. But the V-shape it's a foregone conclusion that we're not going to hit this V-shaped recovery like we hoped. You know, the summer will heal COVID-19. Some of these discussions that were happening like earlier on, that the summer months will inactivate the virus so that you're going to get less transmissions. Obviously, that was not true. So we're going to start seeing some of these impacts continuing. And I think we should really be seeing a U-shaped recovery where, you know, we should expect growth in 2020 across all regions to be impacted pretty bad. And the expectation is that hopefully out of these 150 or so, vaccines that are in the trial phase, hopefully at least one or two of them will come out successful and will help us recover. But 2020 doesn't seem like the year, and companies and industries as a whole needs to prepare for that. All right. Okay, next slide. So again, this is just another cut of this scenario. I want to mention that the IMF has forecasted as a base case about a negative 3% GDP growth globally for 2020. And there's a strong possibility that 2021 could be even more severe in terms of global impact, economic impact. So the way I would see this in a really quick glance is that don't look at the green. That's kind of pie in the sky, hopeful, situation that's not really realistic, as we know now. I think blue is somewhat realistic. The number 2 there, longer outbreak in 2020. We're already seeing in most markets, although the new infection rates have, what they call flattened, so to speak, and even countries like Italy and France, where they were hit pretty hard earlier on, they were able to flatten the curve. But as you can see, it never goes, it will never go away until we have a vaccine or a good enough therapy where we can live with this disease. So like in recent news, Korea has seen a real sharp little tick up, and they're doing whatever they can to suppress that. China's seen a little tick up, and it'll just be a managed, like a whack-a-mole situation where little flares come up, and it'll be up to resiliency of the people to keep this down. What I'm thinking is going to be the real case is that we're going to have this longer outbreak. We're not going to completely dampen and really control, especially in the U.S. and some of these other countries where it's going to continue to be a challenge. But as you may have heard, that a second outbreak, I think we haven't even hit the end of the first outbreak really to even talk about the second outbreak. But the new flu season is going to come up in the fall. And I think a lot of the experts that I've talked to at the School of Public Health at Hopkins and other experts in this field are expecting some sort of a real second wave in this coming fall. And if that happens, then you're going to see this prolonged recovery period, and even more of a shutdown in the first quarter of maybe the end of fourth quarter of 2020 and the first Q of 2021. So in that case, then even the extension of this economic recession will go deep into 2021. Next slide. So what are some of the mega trends that we're already starting to see? We are a resilient group of industries out there, and really looking to not only manage but recover stronger. So some of the mega trends that we're seeing is digital, rise and rise of digital. So I saw a funny post on Facebook, which really seemed true. It was a mock survey of three choices. It said, the question was, what is the biggest accelerator of digital adoption in your company? A, was it your CEO? B, was it government mandates? Or C, COVID-19? And I think it was a little bit of an ironic truth that COVID-19 is the great accelerator of digital adoption across all industries. And then some of the other adoption mega trends there are profit pools are shifting, the value chains are shifting to more of the customer touch points. So industries that are able to really be flexible and agile and address customer needs, the demand, the changing behaviors better and faster is where the value chain really needs to be focused. And then building resiliency. And I think the key point in building resiliency in your company is really addressing the supply chain disruption, because you can't operate a business if your supply chain is impacted by a pandemic of this sort. So you're seeing governments creating new laws and making sure some of the critical supplies to fight this disease, like PPEs and masks, that we've seen where a lot of it was outsourced to China, and when China locked down, there was a big shortage because of that disruption. So building resiliency, whichever industry that you're in, needs to be done, and that's a mega trend. And so lots of investment going in there, and robotics and AI, and to support better insights and forecasting potential disruptions, so you can manage that better, is a mega trend. And then company rotation. So a long story short, what this is talking about is some of these new demands that are popping up are going to require some upskilling and some skills that are going to be in high demand. And obviously, when you have certain skills that are in high demand in such a short period of time, you're going to get a lot of poaching. So how do you make sure that your company doesn't lose a talent for this short rotation, if you will, if you want to call it that? And then how do you manage that talent pool so that you're able to operate in this new world? Next slide. Okay, so second to last slide here. Again, this is just retouching on the 4 categories that we're seeing in the industry position. Strong, like I mentioned, these are industries that were already strong going in. They'll emerge out of this COVID-19 stronger. So consumer tech, pharma. So what are some of the examples of strategies at a high level that they're employing or they need to employ? They need to further invest. They can't stay behind and say, we're already prepared going in. We were already prepared, so this is going to help us ride the wave. I think as if you're complacent and investing and really addressing the value chain and being adaptive, you may lose out to one of your competitors, to be honest. And then transform some of these industries that were strong, but this really impacted their business, like the automotive industry or real estate or travel. They were strong when the economy was going well. There were a lot of automotive sales. Now there's none, right? So their operating model, the strategies they need to look at is their business needs to transform. They need to really lean out. How do they address the operating model challenges and then prepare for the future? So operating model and business transformation will be key. And then oil and gas industries and physical retail, as I mentioned, they were hurting before. They're going to hurt even more and potentially just be obsolete post-COVID. So, the strategies that they will need to look at is, sell distressed assets. If it's not a core part of your business, you need to really look and make the decision to exit as quickly as possible and reposition and really only drive your core strengths to the market, because you won't have an opportunity to manage side projects or assets that are really driving value, right? And then the unknown, the travel hospitality. Now I feel bad for these guys because, these are industries that are meant to make people happy, and travel. I love to travel, and I'm impacted by it, and I'd hate to see this industry get hit so bad. But one of the things that they're going to need to do is to really ride this out. If it's 1 year or 2 year, I don't know how long it's going to last, but they need to really be in this cash position, shoring up and strengthening their financials and doing whatever they can to keep their operations going, because it will end. And we do hope that people will still want to socially engage and take trips and stay in hotels and travel to places like Singapore. So they just need to make sure that their cash position is strong enough to ride this wave out. So last slide here, just another view on strategies. So combining strategy, expertise, and operations capabilities, you can imagine that you'll need to develop some of these risky but short and long-term views on executing these strategies to make sure that you're stronger and better coming out of COVID. So now I think this slide was developed maybe a month or 2 ago, when now was the actual now. But back then, about a couple months ago, cash is king. Every industry really needed to know, like, how long is, like, what are we looking at? Like, is COVID-19, is this a 2-month thing or is it a 2-year thing? Really didn't know. I think companies are starting to understand this better, and I think the whole fear factor has gone over a little bit, and they're now starting to look at the next. But if it wasn't now, obviously you need to understand and how to optimize working capital, support operational crisis and understand the client, how that's disrupting from a supply chain perspective to how last mile delivery, whether it be physical goods or services, reaches the customer in this lockdown environment. But the next, I think all the industries, players or companies are in this next mode. So what now? What do we do next? We've already implemented mitigation strategies to make sure that the customers in healthcare and life sciences, it's all about how do the patients who really need our services get the services. So telehealth was looked at, and some of these alternative ways to make sure that the patients are taken care of. And as you can imagine, every industry has their own challenges on this new normal, as we say. But the next is then supporting operations and really looking at the changed behavior of customer demand and how they'll behave, and what are the logistics that are going to be impacted, and looking at it from a voice of the customer and what they need, and look back and then support the operations that way, right? And then make sure that your resources and capabilities are robust enough and but at the same time flexible enough to address the uncertainty on the new normal, as they say. Maybe upskilling on and the digital. Everything's digital now, so making sure that your firm is upskilled on all things digital, whatever it takes to make sure that you're prepared. And then beyond, I think a lot of the industries are looking at the long term as well, and what would that look like? Maybe they need to address different demands by acquiring bolt-on acquisitions that doesn't require a lot of effort to integrate, a post-merger integration, a shortened post-merger integration aspect, and to drive a lot of valuation. And then also look at divesting for the future as well, and to really focus on your core value to the customer and come out stronger. So with that, thank you for the opportunity. That was my last slide. Thank you.
Thanks, Dr. Chung, for very comprehensive analysis of the COVID impact in a broad scope of industries. And I totally agree that a lot of the traditional business models are now pushed to move digitally. So as an individual, after hearing all the presenters, that we should be able to understand a little bit more how we can protect ourselves, family, and friends. As business leaders, we after hearing Dr. Chung's talk, right, we can protect finding ways to protect our employees' job and reduce our business impacts, maybe driving growth as well. So before we get to the Q&A session, we actually have two poll questions so that we can have an understanding of how everybody thinks about this COVID issue. And the first question is, how long do you think global economy can recover based on your understanding after the three speakers' insights on vaccine, test kit development, and economic outlook? We will have a few seconds, and then we'll share the results. Okay. Let's just give a few more seconds for everybody to go. I see now about 70% of us has voted. For those who hasn't, please click the button. We'll give you another 5 seconds. Okay. Most of us actually thinks it's going to take 1 to 2 years, and that's about 50%, and another 40% thinks that it's going to take 2 more years. That's not so, seems that everybody is not so optimistic about this pandemic. And our next question is, Lenora, can you put the next question there? Okay. Okay, I launched this question already. Which do you think is more effective for confident reopening of the economy? Availability of vaccines and more test kits, or the current safe distancing and face masks? So we give a few more seconds for people to vote. Okay, so 86% of us thinks that vaccine is more important in terms of having a confident reopening of the economy. I guess we can move to the Q&A session. We have 15 questions. I hope that we can cover all these questions within the next half an hour before we can put everybody as a panelist for a chat. So the first question is from Jerry. This question is addressed to Prof. Ooi. Can you please also cover convalescent plasma, its potential role in a broader strategy? I guess this is for vaccine development.
Yeah, so the convalescent plasma basically contains antibodies. So people who have recovered from the infection will develop their own antibody. And the idea is that if we can harvest some of these and then give it to people who are sick with COVID-19, then the antibodies will hopefully reduce the amount of virus in the body and therefore prevent the patient from getting severe respiratory disease. That's the concept anyway. At least the early stage results seems to be promising, but it's still lacking that very hard evidence of a double-blinded placebo-controlled trial, which is really the acid test for any drug. Besides convalescent, I think there's another question asking about monoclonal antibody. It's the same idea. So our antibody response in the body is many different kinds of antibody. But we can also either isolate a single antibody or make them in the lab. And these will only target one specific part of the virus. And that can also be used as a treatment. And one of them is actually ongoing, started clinical trials in Singapore. So we'll see which one works. Well, hopefully we'll have something by this time next year.
Thanks, Prof. The second question is from Alvin. What is the difference between nucleic acid test and the saliva test on the market? Yeah. So I guess this question is addressed to Dr. Wang.
Yeah. So if I understood correctly, the saliva test that on the market is refers to the way of the sample collection. But in the end, what they are measuring from the sample that they collected from saliva is still the nucleic acid. Yeah. Because usually nucleic acid that we use is from the swab, either from the nose or from your throat. So, but in their technology, they can collect the nucleic acid from the saliva. Yeah.
So that leads to one of my questions. Do you think, what is the accuracy rate in terms of using saliva samples comparing to nasal swabs or throat swabs or even phlegm samples?
Based on the studies, the phlegm samples will have the highest amount of virus detected. Yeah, so
it's coughed out from the deep throat, right?
On the sample, so garbage in, garbage out. The accuracy determines what kind of sample, what is the quality of the sample that you get. Yeah.
Mm-hmm. Okay. So there are two more questions for Prof. Ooi. Can you share the planned timeline of your vaccine candidate and how does this compare with the other candidates already in clinical trials? In your view, how realistic is 12 to 8 months target presented by Dr. Fauci? And also, how long is the immunoprotect effects? Can we get infected again after the first infection?
So the second question first, that's a really good question. Nobody knows how long the immunity lasts for. But I suspect that it's longer than what some of the news is saying now. And there's a lot of evidence that people who are supposed to be reinfected, actually they're not reinfected. It's just that they haven't quite cleared all the virus in the body, but nonetheless they're not infectious. So they're actually healthy. The virus is for some reason, we're still detecting the RNA, the genome of the virus, but it's not infectious. So I think immunity would last longer. And coming back to the how long it will take and what exactly is this vaccine and all that. So the vaccine that we're using is an RNA vaccine. So it encodes the genome of the spike protein, very much like Moderna and others. But the unique thing is that this RNA that we're doing, it actually replicates. So it's not just you put in 10 RNA copies, that's all you get, 10. But this one will multiply. And the good thing of it with that is that it's two things. One is that there's a dose sparing effect. You need to give it a lot less because it's going to multiply in the body. Two, that multiplication is actually exactly what the virus does. So in some ways, they're trying to simulate that video that I was talking about, but perhaps not in the full sense of the word in terms of what SARS coronavirus would do. But it's the same idea. The SARS virus will get into the cell to replicate its genome, so that it can make more copies of itself. So our vaccine would also replicate, and so that will actually trigger the right alarm bells in the cell, and hopefully that then elicits the right immune response. Now, because this has never been in human before, it's actually taking slightly longer, right? So like Moderna and all that, as I said, they said, okay, we've done this with other vaccines, so it should be safe. But nobody has ever done this before. So where we are now is we are at the animal stages to show that it works and it's safe. But we are nonetheless quite optimistic that we'll be in clinical trials by August this year. And then, how long will that take? The entire clinical trial take? Optimistically, this time next year is when we'll have a vaccine, if we do get a vaccine.
Okay. So relating to the vaccine question, right? There are two strains that affects the U.S. population and the most of the Asian population, right? So in terms of vaccine development, is there any difference? If I'm vaccinated in Singapore, can I get protected in U.S. as well?
Yes. I think the answer is yes. I don't think that single mutation and all that impacts too much. A lot of that is just in the test tube. So they've never really seen this in humans, that there's no evidence that it's actually spreading more effectively or is evading the immune response. I don't think that coronavirus is like influenza. It doesn't drift as much. So I'm quite hopeful that a vaccine could work. Now, if these mutations could potentially affect the monoclonal antibodies, because these are single antibody and they're targeting one part of the virus. Now, if that part happens to change, then it could affect the potency of the neutralizing antibody. And so that may be a problem for some treatment. But for vaccine, you're developing a whole host of different antibodies, often called polyclonal. And so for a virus to escape so many parts, it's going to be hard. It's like you're firing the bullets at this virus at all angles. It's going to be very hard for the virus to escape.
Thanks, Prof. There are two more questions related to neutralizing antibodies. One question is about whether the neutralizing antibodies in patient specifically protects or it's just IgM and IgG. And the other one relating to this is, could this be a potential therapeutic tool using the neutralizing antibody as a drug against this virus? Yeah.
Dr. Wang, you want to answer the first one since it's diagnosed? No.
So sorry.
Yeah. So the first question is about CPAS kit.
Yeah, the CPAS unit.
In antibody testing, right? That developed
yes.
Professor Wang Lingfa, right? Okay. So this is also a serology test, but it measures not every antibody. It measures the antibody that will bind to the spike protein, which is the lollipop-like structure that Prof. Inyon just mentioned in his talk early on. So these are the antibodies where when these antibodies bind to this lollipop structure of the virus, then the virus will not be able to bind to the protein on the surface of the cell, so that the virus basically cannot get into the cell to initiate the life cycle or the infection of the cell. So that's the whole idea of this CPAS kit. Yeah.
So the second, thanks,
I
Dr.
can
Wang.
continue from there, yeah. So the neutralizing antibody, as Dr. Wang said, right, it binds parts of the virus to disable its ability to get into cell. So you can think of it like, antibody sticking to the key, and so the key cannot slot into the lock. Or you can, the antibody could bind to another part, say the key chain or something. So the key will get into the lock, but you cannot turn it, right? And so as long as the antibody basically stops that process, then the virus is dead, because the virus is not alive when it's outside the cell. It needs to get inside. So as long as stop any of these processes, either the binding or the way it has the spike protein has to turn in order to uncode the genome so that the genome can get into the cell, it makes more copies. If any of those processes are stopped, the virus is dead. So that's the idea of a neutralizing antibody. And that's how the word came about, right? It neutralized the virus from infecting the cell. So the neutralizing antibodies can come in many forms. It can come in IgG, which is the most long-lasting ones, last for 2-3 weeks, or IgM, which is shorter lasting, or IgA. And IgA is secreted into the mucus, the mucosa. And so it could block the virus from potentially even infecting in the first place. So IgG stays in the blood, but IgA comes out into the mucosa. But it's very hard to make IgA right now. And so there's no IgA therapeutic. So all the drugs that we're using are all IgGs.
Mm-hmm. Okay. Thanks, Prophet. So the two more questions for Dr. Chung as well. So there's Mark asked, my company just started a digital journey 3 months before COVID. How long does a company takes?
Yeah, I mean, that's an interesting question. I guess that it all depends on what aspect of the digital journey you're taking. If it's a big ERP or CRM implementation, I guess we've seen, depending on the size of your company, there's a lot of variables that I don't know. But I think, you can expect to at least see, quite sizable investment, and then depending on the scope of that digital journey, maybe I would say in a quick implementation, maybe 6 to 8 months to implement something like that. So I'm not quite sure what the full extent of that question is, but I think on a broader scope, it's not just about a tool implementation, but it's the mindset and getting your organization to think on a digital in a digital way. So what that means is, so think about how it impacts your end customer. If you're in healthcare, how does it impact the patients, and then work backwards. And I think one of the terminologies we use is future back. It's, what is that future going to look like, and how does it impact your customers and patients in my world, and then work backwards and say, what is the right tool to use? And it could be digital and understanding and how to engage with that patient better or that customer better, and then applying that. And I think having a digital strategy first will help in a good way to get to your 80% metric if you're looking at that, and then plan for it that way. So hopefully that gives you some ideas. I'm happy to discuss with you offline. So Ming, if you want to share my deck with anybody who's interested, please share it. It's free to share. And let me know if you want to discuss.
So there's one more question for you. Using your strategic model, can you share your views on which sector in Singapore are most in need of a change? And note that travel and hospitality is described as vulnerable, and they are critical for Singapore.
Yeah, for Singapore, that's a good question. So I don't know the Singapore market too well, but from what I've heard, it's a big transportation logistics hub, right? And yes. In this market, there's a lot of pent up demand. And one of my classmates actually is an executive, a senior level executive at Maersk, and when this COVID-19 hit, and he was in my study group actually, so we're kind of discussing this, and one of the things that he's saying is obviously, you know, a certain percentage. I don't want to disclose the percentage that he mentioned, but it's maybe business sensitive. But a significant slowdown, as you can imagine. But there's a lot of pent up. I mean, a lot of work to be done. Is just in ports not being able to go. And I'm assuming, you know, Singapore, there's a big industry with shipping and things like that, and there's a lot of logistics type of issues. So I think the impact and the strategies that needs to be levied here is what are the technologies to help manage it more effectively, efficiently, and not increase the cost of a supply chain, and how do you manage that the demand that's being built up when this whole COVID thing reduces and the regulations open up. How do you make sure you go back to normal without a spike increase in cost? So cost management, I think, is going to be a key challenge for that industry.
Thanks, Dr. Chung. I think we are running out of time, but I guess we have to be interactive. So Lenora, can you open everyone to be panelists so that they can ask questions? We haven't addressed all the questions yet, but if you have any questions, please do raise a hand, and then we can openly discuss about these other questions. Lenora? So in the meantime, right, maybe we cover one or two questions. One of the questions is for the first two presenters. I would like to know about international cooperation and country by country differences, both on vaccine and tests. Vaccines and tests approved separately country by country. Is there a good cooperation and exchange of scientific results between countries? How about IP rights? There are cases where countries trust or distrust other tests or vaccines used in other countries, which may hamper travel between certain countries more than between certain others. So this question was asked by Michael for Prof. Oi and Dr. Wang. Okay,
well, there is a lot of information exchange, and sometimes it's more like how do you deal with the explosion of information. I think amongst the regulators, like in Singapore, the Health Sciences Authority, the FDA in the US, the European medicines agencies and all that, there is a regular meeting on what they're learning from clinical trials, what they're learning from some of the vaccines and drugs that are getting into the clinical trial stroke market space and all that. So there's a lot of exchange of information amongst the people who are trying to develop a vaccine. There's some level of exchange of information, but there's some level of competition. And I think the competition is good because it actually spurs us to be more creative, to be more, to really push our technology, our abilities and all that. And the kind of timelines that we're talking about is unheard of. There's never been a vaccine that gotten from concept to clinical trials in months. It's always years, and so we're breaking all sorts of world record right now. So I think there's one question I read whether it can be better. I think it can be better, but that's for another time.
So there's one more question about US. Why US is hit so badly this time when there's to control this pandemic?
Yeah. Well, I think the US responded late, and once you have a lot of cases built up, one passing to two is an exponential growth, right? Once you get into that phase, it's really hard to bring it down, and so that's why the entire strategy in a lot of countries is to try and suppress it as much as you can, so that you don't build up that reservoir that keeps spilling over. And I think that there's a price to pay with any control of any infectious diseases. It's you're trying to balance the cost versus the benefit. I mean, obviously there's benefit in trying to control any COVID-19. You're going to lockdowns, you're going to circuit breakers and all that, but there's a cost associated with it. The question is whether the cost justifies the benefits justify the cost, and that's a hard thing to do.
I think we have two more questions and then we can close out the meeting. So Hiro asked, some IVD companies provided coronavirus 2 antigen tests. Do you think it will be major test in POCT? This is for Dr. Wang. And what is the minimum amount of copies of COVID-19 PCR detects in 1 week's time period?
The minimum amount requires the limit of detection, depending on the limit of detection that the test kit used. So usually from the market or the test kit, the PCR test kit, the limit detection ranges from range from 50 copy numbers all the way to 200. So that's the limit of detection. So these can be used as a ballpark for the information, right? So the other question, POCT.
The other question is antigen test kit. Do you think it will be the major test in POCT?
So the antigen test kit is also a very interesting topic nowadays. I think at least from the FDA website, the EUA, I think they also open up the antigen test submission. But in my view, because this is a respiratory virus, so for antigen test, because the antigen test usually suffers from the sensitivity, depending on how much of the viral protein that we can detect from the human body. So because this is unlike the dengue virus or the HIV, which is a bloodborne, that the virus circulates, replicate in your blood. So usually you will get a lot of amount of viral antigen, mainly is the viral structural protein. But in this case, it's a respiratory protein, a respiratory virus. So what is the concentration level that we can get from the body fluid? So that's a question that pose the challenge for the really sensitive and accurate antigen test. Yeah, that's just my view. Yeah, maybe Prof. Kim Yong can add on. Yeah.
Thanks, Dr.
Well, no, I think you've covered most things, and yeah, sorry, it's getting late.
Is there any questions from the floor? Please unmute yourself and then ask our panelists if there's any questions. Do you have any comments that you want to post? Well, anyone from the floor? Okay. No questions. I guess that's all the time we have. Thank you so much, Prof. Oi, Dr. Wang, and Dr. Chung to speak with us today. And for all the participants, thank you for joining us and supporting this alumni event. Keep in touch through our alumni social media channels, LinkedIn, Facebook, Viber. We have all the social media contact points. And keep a lookout to our future events as well. Thank you, everybody. Have a good night.
Thank you. Yeah, thank you. Yeah.
Thank you. Bye.
Bye.
Thank you. Bye-bye.
Bye-bye.